This video, I will be showing you another way to solve systems of equations. Before we have Gaussian elimination with row pivoting, substitution, elimination, and many others. But in this video, we will be trying to use this LU decomposition, and I will be showing you how to do it. So in LU decomposition, there are just three formulas you wish to remember. And these are AX equals B, LY equals B, and UX equals Y. So now, what is A, what is X, what is B, what is L, and what is U? So to fully understand what are these letters, let's have this example and I'll show it to you. So if we convert this particular systems of equations, we have the coefficients, which are 4, 4, negative 2, negative 1, negative 8, 1, 1, 5, 1, 1, and 5. And then we will make another matrix for our unknowns, which are x, y, and z, and equate it to the constants. So the constants are 7, negative 21, and 15. So now A here refers to this matrix. So the matrix of the coefficients of the equations, right? That's 4, 4, negative 2, and so on. While this here, x, y, z, are the unknown variables, we call that matrix X. Matrix A times matrix X is equal to the constants, which we call it B. So now, AX equals B. So A is just the matrix of the coefficients, X is the matrix of the unknown variables, and B is just the constants. So now, L there, as you can see, there is L, refers to lower triangular matrix. So, lower triangular matrix just means that above the diagonals, we should have zeros on it. And also, the diagonal should be consist of only ones. And here we have multiplier 1, multiplier 2, multiplier 3, and so on. So this is lower triangular matrix. That's L. While upper triangular matrix, this U here just refers to a matrix that has 0 below of it, while its diagonal could be any number. Sana lang iyahang kalainan. This is U, or upper triangular matrix. This is L. This is A, matrix of the coefficients, X, matrix of the unknowns, and B, matrix of the constants. So don't worry, because AX equals B is just from the given equations. This U and L is the one we're going to create. Ano siya ito ang himuon actually in LU decomposition. So L refers to lower triangular matrix. U refers to upper triangular matrix. Here, it doesn't necessarily need to be 0 above. And here also, for U, the diagonals don't necessarily need to be number 1 or 1 on that. So now, how do we create the upper triangular matrix? Well, we can do that by manipulating this matrix here, the matrix of A. So if we again to convert that, we will have to, what do? We will have to make 4, negative 2, 1 as 0. We will eliminate that by basing it to 4, negative 8, and 5, the numbers in the diagonal. So that's our pivots, right? So if we copy that, 4, negative 1, and then 1, we will change 4, right? So we will multiply this entire row here with a number, so it will cancel out this row 2. So if we multiply negative 1 to row 1, so negative 1 row 1, and then add it to row 2 and make that our new row 2, so this row, we will have negative 1 times 4 is negative 4 plus 4 is 0. So we will have 0 here. And then negative 1 times negative 1 is positive 1, right? Minus 8 is here 8. Negative 1 times negative 1 is positive 1. Minus 8 is negative 7. And then this here, that's, above negative 1 times positive 1 is negative 1 plus 1 is 0. And then here, if we want to cancel out negative 2, we will multiply 1 half to 4. So 1 half row 1 plus row 3. So 1 half times 4 is 2 plus negative 2 is 0. And then 1 half times negative 1 is negative 1 half plus 1 is just positive 1 half. And then positive 1 half times 1, here 1 half times 1 is 1 half plus 5 halves, plus 5 is equal to 5 plus 1 half. Right? 1 half plus 5. 1 half plus 5. 5 plus 1 half. Lang. And then, our lower triangular matrix is based on our multipliers. So, di ba? Ningon tama, this should be equal to 1 and the above should be equal to 0 if lower triangular matrix. So, our first multiplier here, as you can see, is negative 1. So, ang dapat natong ibutang dire sa ato ang 1 is the opposite sign. So, if negative 1 ang ato ibutang sa multiplier 1, the first multiplier we use should be the opposite sign. So, if negative 1, positive 1 ibutang dire. Here, our second multiplier is positive 1 half. So, we will put negative 1 half here. So, this is how we create our upper and lower triangular matrix. And again, from this, how do we eliminate 1 half? By basing it to this negative 7. So, that's our next, in our diagonal. So, we will do 1 half divided by 7. So, 1 half divided by 7 is equal to 1 over 14. So, we will just multiply 1 over 14 on this row and then add it to row 3. And that would be our new row 3. So, just copy this. So, 1 over 14 times 0 is just 0 plus 0 is 0. 1 over 14 times negative 7 is this one. It's just negative 7 over 14 or negative 1 half plus 1 half is 0. Then here, 1 over 14 times 0, alright, is 0. So, plus 0 plus 5 plus 1 half. Maulang na. 5 plus 1 half lang gyapon 5 plus 1 half. So, now, our third multiplier or M3 is 1 over 14. So, we will put here our M3 as 1 over 14 but negative. So, the opposite sign, negative 1 over 14. So, now that we have our A, X, U, and L, so this is now, we can erase this, and replace it by our newly created U and L. Just like that. Oh yeah. As you can see, it already follows what we want. So here, lower triangular matrix, 1, 1, 1. And here, 0 above. Upper triangular matrix, diagonals isn't actually 1. Don't necessarily equal to 1. But the lower here are zeros. So now we will just apply it to the formula. So it says that AX equals B. So mane. Again, the next is ly equals b. So our L is just this one, L. So we will just say 1, 1, negative 1 half, 0, 1, negative 1 over 14, 0, 0, 1 times, this is our L, right? Ly. So for y, you just have to put y1, y2, and y3. Just like that. And that's equal to b. So our b here is this 7, negative 21, and 15. 7, negative 21, and 15. Just like that. And now we can now solve for y1. Right? y1 is just equal to 7. y1 is equal to 7. And then 1 y1 plus this one plus 1 y2 is equal to negative 21. We know that y1 is equal to 7. And so, if we transpose that, we will have y2 equals negative 28. Negative 28 because 7 times 1 is 7. Transposing it will give negative 7. So, negative 21 minus 7 is negative 28. Kamihan na to. And then, this third, we have negative 1 half y1. Negative 1 half y1 minus 1 over 14 y2. That's plus 1 y3 is equal to 15. Right? 15. y1 is equal to 7. y2 is equal to negative 28. And so y3 is equal to y3 is equal to 16.5. So let me just clear this. So we have y1 equals 7, y2 equals negative 28, and y3 equals 16.5. Now, our next goal is to substitute what we know to this formula here. Ux equals y. So, upper triangular matrix. So, this one will just use this. Ux. So, u. Then, for our x, this one, our x is just the unknowns. So, x. This is our x. That's equal to y. Or the y1, y2, and y3. Here, x, y, and z. But we already know what's y1, y2, and y3. These are 7, negative 28, and positive 16.5. So we can just use this 5 plus 1 half. 5 plus 1 half z, so this one, is equal to 16.5. Thus, c is equal to 3. If you use your calculator. Then, this row. So, all we have is this one. This is x, y, z. All we have is negative 7y. That's equal to negative 28. And thus, y is equal to just 4. Alright. And then, finally, 4x minus y, 1y, plus z equals 7. This is negative 28. This is 4 di. For x is equal to unknown. That's what we're looking for. So for x minus 4y, minus 4 plus z is equal to 3. So this is negative 1. And then transposing it, we'll have positive 1. 4x equals 8. And so x equals 2. And so this is how we use LU decomposition to solve systems of equation. I hope you got something here. Like, share this video to your friends. And thank you so much for watching. Peace out.